Hello everyone and welcome to the first virtual Canadian AI conference. I'm Gashin Ghazizadeh and today I'll be talking about CB-DBSCAN, a novel clustering algorithm for adjacent clusters with different densities. Today's outline is going to be an introduction to clustering and why is it important, what are the different clustering algorithms that are out there, and then we'll continue by explaining the problem of multi-density clustering, and then we will explain our proposed algorithm and show the results for it. Why is it clustering such an important task in computer science? There are a lot of data that are unlabeled, and labeling is often very hard and needs a lot of expertise. Therefore, in most of the cases, we end up with a lot of data that is unlabeled, and clustering is the solution for that. With clustering, we can find groups of data that are similar, and then we can find the characteristics of these groups. There are two main different clustering algorithms, density-based and center-based algorithms. DBSCAN is one of the most famous clustering algorithms that is a density-based algorithm. It tries to separate clusters, find clusters based on the dense regions in the data space. DBSCAN has one problem, and it is multi-density clustering. As you can see in this example, we have two clusters that have different densities, but they are adjacent to each other. So if we want to choose a set of parameters that satisfy both of these densities, we end up combining them as one. Why is that? Let's take a look at these clusters. We have different core points and border points in both of these clusters, and we have a set of parameters that will satisfy both of these. Therefore, the boundary points that are between these two clusters will end up being density reachable from both of these clusters, and therefore they will be connected together and will be returned as one cluster using DBSCAN. We came up with an idea to solve this problem. CB-DBSCAN is an algorithm that contains several basic steps. First, we try to produce mini clusters using DBSCAN. And then we try to merge these mini clusters in two different levels, and by combining them, we will have our final clusters that will solve the problem of multi-density clustering. In the steps of producing mini clusters using DBSCAN, there are a lot of noise points that are produced. So we want to assign those noise points back into their original clusters. CB-DBSCAN has two additional parameters, CDs and DDs. CDs is the parameter for the threshold, and the threshold is for the difference in the center of clusters, and DDs is the threshold for difference in the density of clusters that we want to combine together in the merging steps. But how do we choose the correct parameters for DBSCAN to produce our mini clusters? There are different outcomes for DBSCAN if you choose different parameters. Let's take a look. This is the first possible outcome if we have two adjacent clusters with different densities. As you can see, the parameters have been set in a way that both of these clusters are break into smaller ones. Using the merging steps in our algorithm, we can correct these type of outcome from DBSCAN, and therefore we will end up with the proper clusters that we are looking for. Next step is when we break the sparser cluster into smaller clusters, but we have the denser cluster separated very well as one cluster. This is actually one of the perfect outcomes that we're looking for from DBSCAN. This one as well can be corrected, and the mini clusters can be combined to form the final clusters that we're looking for. Next one is an outcome from DBSCAN that we cannot correct using our merging steps. As you can see, the global parameters have been chosen in a way that these two clusters are combined and returned as one cluster. There are no mini clusters to be merged, so our merging steps cannot correct them. And finally, we have the perfectly separated clusters that have different densities, but this one is not a possible outcome in most of the cases using DBSCAN. Therefore, the two first cases are the outcomes that we're looking for from DBSCAN for our mini clustering step. Merging steps. Let's take a look at an example. Here we have the data points, and then we use DBSCAN to produce our mini clusters. And then we try to combine these mini clusters in a chain way, like for the first step of merging. We start with the green mini cluster. We calculate the center and density of all of these clusters, and then we compare the green mini cluster with the orange one. We see that their density are the same, their centers are close, therefore we add them to this chain that is going to be combined all together to form one cluster. And then we'll continue by the pink one, and again it will be added to this chain, and therefore these three mini clusters will be all combined to form one final cluster. But on the other hand, if you look at the light blue cluster, it has a different density from these mini clusters, and although it is close to these mini clusters, it won't be added to this chain. And with the leftmost mini cluster, it has a density close to the mini clusters, but the center difference between these two mini clusters is greater than the threshold, therefore it will not be added. And also, as you can see, there are a lot of noise points that are produced during the mini clustering step, that these noise points will be merged to the final clusters after this stage based on their distance from the final clusters. The second step of merging. There are some cases that the density around the boundary areas are different than the density in the center of the cluster. And therefore, we don't want to separate these mini clusters that are produced at the boundary areas, and we want to have them in their final cluster. Sometimes you might end up with a case like this, when the mini clusters are merged in the chain way like in the first stage. Because of the density difference, we might not combine them with the mini clusters of the center of the final clusters. When we have this case, we want to combine these two clusters together so that the boundary points will not be separated. Therefore, in this stage, we focus more on the centroid distance rather than the difference in the density. And as you can see, we are using the same parameters, but we use the half of the CDs, and DDs is multiplied by 3, therefore we're not focusing on the density difference. And therefore, with this level of merging, the boundary points will be in their original cluster, and they will not be separated as another cluster. Let's take a look at the results of our method. As you can see here, we have 5 different datasets. These datasets contain both synthetic and real datasets. And as you can see, we have compared our method to 4 other methods that are for clustering, 3 of which have been proposed to solve the multi-density clustering. And as you can see, CB-DBSCAN can overcome the problem of multi-density clustering and has a better result in almost all of the cases in comparison to these other methods. Also, we took another step and used Twitter data as well that are talking about different topics. We used the word embeddings to produce a vector for each tweet, and then we used the CB-DBSCAN along with DBSCAN to separate different topics, and as you can see, CB-DBSCAN has a significant improvement over the baseline DBSCAN. Thank you so much, and I'll be happy if you have any questions to ask me. And here is our references. Thank you.